Hello students, welcome to chapter 12 linear programming. Students, in linear programming we continue today our exercise 12.1. Question first. Find the maximum value z 3x plus 4y to given subjects by the LP problem solutions, means linear programming. I take here first of all line L1. So x plus y converting into simplest table, putting x0 y4 y0 x4 and check to 0 0 related. Your x plus y less than 4, it is surely true. So your graph now running towards to origin sides, definitely. Yeah, 1 2 3 4 4 3 2 1 1 2 3 4. It is 0 4 4 0. Just connect the lines by the L1. X plus y is equal to 4, and your graph towards the origin sides, this sides. That's it. And definitely you have the points, corner points 4 0 0 4 and 0 0. So my last answer table here done. Yes, points, corner points of feasible region, either feasible area. In Z I will define to 3x plus 4y, but it is the maximize. A 4 0, B and O, it is 0. 4 3 is 12 and 0, and here 16. So that's your maximum at B 0, 4. Now question second, students. Very easy. Subject to asking that question number 2, and my question is that, yes, find the maximum, minimum value. Find minimize of the z, and some conditions given, subject given. So asking the z related to your questions, minus 3x plus 4y, and subject given x plus 2y less than 8, 3x plus 2y less than 12, x and y both positives, and minus 3x plus 4y I want to minimum value. Very easy. First of all, we derive that line converting to table. So this line L1, x plus 2y is equal to 8. Go to simple table and respectively putting x and y alternately 0. So here x0 then, students, y is 4, but y0 then, x is 8. y0, x is 8, and checking to 0 0. So it's have to x plus 2y less than 8. It is true. And secondly, same line L2. Similarly, students, second one, 3x plus 2y is equal to 12. Go to table. x0, y6, but y0 then x4, 12 by 3. Yes, 0 0 checking. 3x plus 2y, it should be less than or equal to 12. So 0 plus 0 less than or equal to 12, and it is surely, it is true. Yes, so my graph have to y, x, easily I just derived that it is 8 and 4. I will go to 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8, and go to tables for 0 4 8 0, and line join that L1 line. Check your graph, it's towards the origin, this side, students. Second 0 6 4 0 and that's the intersection points. Is the graph again towards the origin? It means this sides. Finally, your answer is that much as point A 40 and point B 04. P students, here you can derive by the simple elimination method, and you will derive simple your answer to question number 2, and then after I will go to my table values. So students, in elimination method, L1 intersection L2, I will just show that at the point P, this is your L1, that's your L2. So x plus 2y, second 3x plus 2y, and derive simple solutions. This cancel, minus 2x minus 4, x become 2, and if you taking x to 6, 8 minus 2 6, 6 by 2 which is 3, I mean 2 comma 3. And now you will go to finally tables. So corner points of feasible region, and here derived to z minus 3x plus 4y. So just structurally putting the point here 40, next B point 04, and P is a 2 3, and that much is answer is easily done. So here 4 is a 12 plus 0 minus 12, here 0 16, and last one minus 6 plus 12 6, but I want to answer minimum, so that's your minimum answer. So at a 40, minimum value of z is become exactly minus 12. Now continue question number 3. Same is subject given and decided to minimum and maximum both values. So in the subject wise given the question 3rd, yes, find here only maximum value. Find maximum of z given 5x plus 3y. Yes, 5x plus 3y. In the subject given students, 3x plus 5y less than 15. 5x plus 2y, 5x plus 2y less than 10, x greater than 0, y greater than 0. It's very easy students. Just I will go to line L1. 3x plus 5y is equal to 15. Go to table. Simple derive x0, y3, but y0 then xy. And 0 0 you just check about that. 3x plus 5y less than 15, 0 plus 0 less than 15, which is definitely it is true, because 0 less than or equal to students 15, you go to true sides, I mean towards the origin side your graph. Second line L2, my L2 line is a 5x plus 2y is equal to 10. Same plotting, x0 y5, but y0 x2 10 by 2, and checked about 0 0, 5x plus 2y less than 10. It is 0 plus 0 less than 10, which is conformly true. Means your graph easily you will plot here to x-axis and y-axis. Check here 3 5 and 2 is 1 2 3 4 5, 1 2 3 4 5, 5 4 3 2 1. My first plotting is 0 3, second 5 0, and both of the joint, and check that line L1 towards the origin, means this side. Second also 0 5, and here 2 0. That line also I just connected between the 1 points, and this also given the towards the origin sides. Both of the origin sides means this shading is my final shading, and very easily your answer A.20, B point 03, and students P, L1 intersection L2, you will decide it by common intersection between that 3x plus 5y is equal to 15, and second 5x plus 2y is equal to 10. Solve by elimination, you will get x and y just like 20 by 19. And secondly, students, I already calculated here, that's why I write down 20 by 19 and 45 by 19. Put it here in the 20 by 19 and 45 by 19. Now go to finally table, corner points and the answers. So here I will go to corner points of the feasible region, feasible area, and Z I want to 5x plus 3y. Just value put it as much as possible and calculation. Your A point 20, here 5 to is 10, second B point 0 3 is 0 3 3 is 9, and P point is a 20 by 19, 45 by 19. Just put it here. So 2500 by 19 plus 45 3s are, yes, 45 into 3, which have to, I think, 2 to 5. 5 is a 15, 1, 12. 5 is a 15, 5, 1, 4 is a 12 plus 1, 135 by 19. And that much, students, your answer is finally 235. Yes, correct answer, 235 by 19. And that's your answer for asking what that it is a maximum. Yes, here your maximum value at the place of P, 20 by 19 and 45 by 19. Next, students, continue for question number 4, and but 4 is a cancel there according to board guideline. So I will go to question number 5. 5 also, but IMP, most IMP questions coming here now in the 5th one. Find that in 5th maximum value of Z 3x plus 2y. Z is a 3x plus 2y, but subject given x plus 2y less than 10, 3x plus y less than 15, and x and y greater than or equal to 0. Again I reading 3x plus 2y maximum, x plus 2y less than 10, 3x plus y less than or equal to 15. Yes, and asking that maximum value. Very easy, students. First of all, I will just plot my graph, and before graph I will decide it the points. So here L1 line, take the L1 line, x plus 2y is equal to 10, and just go to simple x0 y5 but y0 x10, and check the 0 0 values. X plus 2y less than 10. I will go at 0 0 less than 10, which is true. Now second line, L2 for that, 3x plus y is equal to 15, and apply the same as think about that table. X0 y15 but y0 then 15 by 3 5, and here checking to 0 0. I mean this line itself passing through origin or not shading, that I my answer 3x plus y less than 15, 0 plus 0 less than 15, and it is the true. I mean my shading origin side is going 0 less than 15. Now I will start my graph. Y-axis, x-axis, and values is a 10 and 5. Very easy. 5, 10, 15. Here also 5, 10, 15. It's very easy. First 0, 5, second 10, 0, line L1, and shaded which sides? Yes, it is true sides, origin sides. This side is my shading. Now secondly 0, 15 and 5, 0. That also, students, I will show that in the point of intersection to something point P, L2 line, and my answer is also going to origin sides, means this sides, that side you are shading. Means my common shading is this, and that common shading is your answer related 5 0. B is 0 5, but P is both common intersections. Yes, here I will show two common intersections between that. L1 intersection L2 is a P. Xn here X secondly. So students, I will just here multiply by 3. 3x 6y 30, and that same 3x plus y 50. Let's cancel. It's a 5y is equal to 15, y is equal to 3, and x become, yes, y3. You put here 3 to the 6, 10 minus 6, which is 4. I mean 4 comma 3. And go to finally tables. Yes, feasible region related. Your final answers 1, 2 and 3 points. Yes, corner points. Of the feasible region, either feasible area, and Z asking here 3x plus 2y, but in the maximum value. So my first point A 5 0, 5 3 is a 15 0. Second B 0 5, so it's a 0, 5 is a 10, and last value it's covered to P 4 comma 3. Here 4 is 12 and 3 to the 6, 18. Yes, 18 is your final students maximum value. So here your maximum value at which place? P 4 comma 3. Yes, correct answer. Now 6 also cancel students. So I will go to now 7th. 7th is a really IMP questions. It's the most IMP questions. Question number 7. Many times asking in exam. So I will tick in the IMP list. Find in the 7th one maximum and minimum. Find maximum and minimum value of Z to given, that is a 5x plus 10y. 5x plus 10y, and the subject given, my subject is a x plus 2y less than 120, x plus y greater than 60, and x minus 2y greater than 0, and xy greater than or equal to 0. One more time check. X plus 2y less than 120, x plus y greater than or equal to 60, x minus 2y greater than 0, and subject 5x plus 10y. So students, here actually three equations given, and all three I one by one just carry forward in the tables, and then after graphs. So students, here first L1 L2, this is a mean steps, because this line itself passing through origin, that's why this numerical is a IMP. So line L1, that is x plus 2y is equal to 120, x plus 2y 120. Go to table, take the sum points, x0 y60, but y0 x120, and go to origin towards checking or not. It's a less than or equal to 120. So 0 plus 0 less than 120. Surely it is true. Means my graph for this L1 line towards the origin. Now second line L2. Second line L2, x plus y is a 60. Simply going x0 y60, but y0 x60, and here I will check to x plus y, it's greater than or equal to 60 or not. Very easy. Here apply 0 plus 0 greater than or equal to 60. It is false, because 0 is not more than 60, means my graph not passing through origin. And third line L3 is this one, x minus 2y is equal to 0. Yeah, this is the mean. Here I will take x0 then y0, but if you take y in this table of 30 60, so y taking 60, x is a 120. If you another number is also taking, that sufficient too. Here students, y is become 30, then x is 60. And here I will check to some points, but not the exactly fix. It is defined by according to drawing. And x minus 2i greater than or equal to 0, I will check. Now I go to graph. X-axis, y-axis, and just taking 30, 60, 40 up to 120. So 30, 60, 90, 120, 1, 2, 3 and 4. 30, 60, 90, 120. And decide first these lines 0 to 60. Second 120 to 0. Go to line L1 and shading portion towards the origin. Yes, this side you're shading. All portions. Now second 0 to 60 here same, 60 to 0 means this one. And this shading is a false, means opposite to origin sides, means this side. This sides. And third one 0 0 here, 120 to 60. 120 to 60 means here. This side you're passing through lines. And third 60 to 30. Here 60, definitely it is 30. It is 60 comma 30. Just I will check my L3 line. X minus 2y is equal to 0. Put it x 60, y 30. And it's intersect to same as your line number L1. This is an L2. Your line number L1, if you're taking here x60, definitely y30. Check x60, 120 minus 60, 60, 60 by 2, that is 30. That's your point intersections. And your graph now, this line L3 have two half plane, one of the this, one of the that. Just I will take two here points P, checking to this side shading. If you this true, then my shading portion is this, either that. So 60 comma 30 here I will check to here 60 and 90. So x is 60, y is 90, 60 minus 180, it is minus 120, and minus 120 is not more than 0, it is false. It means this side shading portion for this line L3 is not possible. I going to that side, it means this side moving. So my answer is this. To according to all three lines are shaded portions. This is point Q, that is R, here A and here B. 120, 0. It's the 60, 0. Q also ready. Only R is my target now. L3 and L2. Yes. Now L2 intersection L3. Yes, L3 intersection L2 is the point number R. Is the L2, that's the L3. X plus y 60 and x minus 2y 0. Let's define elimination. Minus plus minus, this cancel. 3y. Y becomes total 20 and y 20. If you put it here, 60 minus 20, 40x. Yes, x become 40, y become 20. So it is 40 comma 20. Now finally answer. Here I will show that feasible region related my solutions. Yes, corner point of feasible region, either feasible area. And my z is, students, 5x plus 10y. I want to both maximum and minimum. So my first point is A, 60, 0. Second B, 120, 0. Thirdly same P, R, 40, 20. And last Q, 60, 30. And respectively put down the values. So 60, 6 5 is 30, 300 plus 0. 120, 600 plus 0. 40, 4 5 is 20, 200 plus 200. It is 400. And last 6 5 is 30, 300 and 300. It is 600. It means maximum value at this place are the maximum, and minimum students at that 100, this is a minimum. So after that you will write down in the statement wise at these 2 points are the maximum, and here 60,0 is minimum value students 300, and that's easily students you will cover your answer. Now I will go to 8th one. 8 is also same as and the same concept, just value for given that 3 different inequalities to relate maximum and minimum answer. So similarly students, in question number 8 also IMP for exam related. It's also many time asking. So you will tick mark in IMP list. Question number 8. Solve by LP problems and find out that minimum and maximum value. Find maximum and minimum of z that given x plus 2y, and the subject given students x plus 2y greater than 100, 2x minus y less than 0, 2x plus y less than 200, and xy greater than or equal to 0. One more time check. Z is a x plus 2y value students, and x plus 2y greater than 100, 2x minus y and 2x plus y less than 200. The same concept, only the value is different students. So this question also IMP because these lines are indicate that are in the 2 half planes of individually. So first of all I will start here. Line L1 x plus 2y, it's become 100, and go to table x0 y50, but y0 x100, and check to originality 0, 0. So x plus 2y is greater than 100. So students, here 0 plus 0 greater than 100, and 0 greater than 100 not possible, it is false. It means your graph not passing through origin sides. Now second, line L2, these are 2x minus y is equal to 0. So your just table y become 2x. Here you will take some points x and y. If you are taking x0, definitely y0. Another point depend on that taking. It's very easy. So here 2x, x taking 50, y 100, x taking now 25, y is 50. Just like 25 2s are 50. And another point also possible, but here I will check two different points on that 2x minus y less or equal to 0 in the graph. Now third, line L3 is that 2x plus y less than or equal to 2x plus y less than 200. Here also same as students, you will to take in is equal to and define to table x0 definitely y 200, but y0 then x 100, and check down to 0 0 sides. So my 0 0 sides 2x plus y less than 200, it is 0 plus 0 less than or equal to 200, and definitely 0 less than 200, which is true. Yes, it is true. Now we go to graph. That's your graph. X-axis, origin, y-axis. And your value is 100, 200, 50, 25. It's very simple. Here 25, here 50. That's the 100. Here 150. And here 200. Similarly students, here 50, 100, 150, 200. Approximately taking 0 to 50, 100 to 0. Both are connected by the line L1. And shading portion students, it's the false, means not passing through origin sides. This to opposite to origin side, this sides. that one. Now final drawing I after that plot. Now secondly here 0 to 0 means that one, 50 to 100, x 50 y 100 means here, and second 25 to 50 it is here, and this line are passing through on it this way. This is your line L2 students. 2x minus y is equal to 0, and just to check here 25 to 50 sides. It's very easy. X 25 taking in this parts, if you then 2500 minus 25 75 by 2. So exactly it is here passing through above that. And now this line have two parts, one of the upper parts, one of the lowest parts. So as well as you will taking if you upper parts and lower part shading. So I will just check 50 to 150. Just checking in the point P, x 50 y 150, and apply here 50 to 150. So you will get 50 to the 100 minus 150, and check it is true or not. Yes, 100 minus 150, which is minus 150. I mean minus 50 less than 0. Yes, it is true. Minus 50 less than or equal to 0, and definitely my data is true. It means your graph to these lines that sides, this side your graph moving. Now third line is remaining. Yes, in this portions both of the lines are common regions, and third line 0 to 200 and 100 to 0, and that what you also shaded portions, you know that it is also true, means towards the origin, means this side you're shading here. Final shading you get this one. So that point is point number Q, and here taking point number R in both common intersections, and you will decide a final answer. Here point A I will take 0 50, here B taking 0 to 100. Now students, one more time I repeat, this is L1 line, that is the L2 line, and that is your L3 line. So first of all I define R, L1 and L2, L1 and L2, L1 and L2 is R. Your L1 is a x plus 2y, and secondly that 2x minus y. So here multiply by 2, 4x minus 2y. Simple, you will get your answers. 5x 100, x become 20, and also students y, you will decide that x 20, here y 20, 2 is a 40, means point number R ready, 20, 40. Now define to Q, and Q also as much as same as eliminations. Students, I will go to elimination wise to next parts. Also to Q points L2 and L3, means this L2, that L3, L2 intersection L3 is a point Q. So this 2x minus y, and here students 2x plus y, it's very easily cancellations, that 2x minus y is equal to 0 and 2x plus y is equal to 200. So what you get, this cancel. Simple, your data is a 4x 200, x become 50, and if you students x 50, then y also ready, x 50, y is a 50 to the 100. Yes, that's become your 50, 100 answer students, and here that much you easily getting. And now students, I will define to my final table solutions. So students, now in table wise solutions, we decided my final table to that minimum and maximum value defined to in these values. So corner points, of the feasible region, corner points of the feasible area, and Z I have to x plus 2y, and answer obtained at maximum and minimum. So this corner point applies at A 0 50, B 0 to 100. Now Q 50 100 and R to that 20 40, and very easy, just value put it. Here 0, here 100, second 0 but 400. Next will be that going to 550 and here 200, which is 250, and last 20 plus 4 to the 80 is 100. It means you have to maximum values at that is your maximum at B. Yes, so my last answer at B 0, 200 maximum value, it's become 400. And students, minimum at A 0 50 and secondly R 20 40, minimum value is that 100, because the two values placed here minimum and that also minimum, and both answer is, students, easily done here. Now after that, students, question number 9 and 10 and other all questions of these chapters are according to syllabus wise, their board guidelines, it is cancelled. That's why, students, here our chapter is over and I will stop this video. In further explanation, students, we have to new chapter. I will explain in the next parts. Okay, bye bye.